Hello everybody, welcome to this vlog. My name is Satya. Today I'll be discussing about a transport layer protocol which is called as TCP. TCP stands for Transmission Control Protocol, and it's a very reliable protocol at the transport layer. Right? Let's start discussing about the topic itself. First point, as I mentioned, TCP stands for Transmission Control Protocol. It provides reliable connection over transport layer. Right? How it provides reliable connection, I'll discuss in the third point. It accomplishes reliability by having handshake mechanism which involves synchronization ACK and acknowledgement. Right? So when you start communicating in the browser, which is for example HTTP, it is usually based on TCP handshake on the transport layer. Right? Transmission Control Protocol. So what it does is, when you start http://www.google.com, it finds, as in my previous videos I have discussed about DNS, domain name system. www.google.com is first resolved using a DNS query sent to DNS server. Residential router will proxy that DNS query to the ISP backbone DNS server. After you getting a reply as an IP address, whether it's IPv4 or IPv6, you start communicating with the server. That's what we discussed in the last videos, right? And this is our 8th installment of simple home network setup. Once you receive the IP address and start communicating with the server, first you have to establish a reliable connection. That reliable connection is established by sending a SYN to the server, synchronization message. That has to be acknowledged by server using synchronization acknowledgement, and this synchronization acknowledgement is again acknowledged by the client, a TCP client, by acknowledgement message which is called as ACK. So each session will have a unique sequence number. Once you start communicating with the server for a particular URL for a transmission control protocol transport layer session, it will send SYN with a sequence number, like say for example 1000. The SYN-ACK will contain a sequence number saying, yes, I acknowledge your sequence number. I will record it as part of my session details, but this is my session ID, which it will be acknowledging with saying this is my sequence number, which is 3000. Now server responds with another sequence number saying 3001 to acknowledge the session ID from the server for 3000. So from the client side it is 2000 sequence ID. It is acknowledged by 2001 sequence number by server. Server sends another SYN-ACK with the sequence number for its session with the client, that is having sequence number of 3000, and it is acknowledged by using 3001 by the client. So as specified in the fourth point, the initial connection establishment involves SYN-ACK and acknowledgement. So now it should be very clear for everybody what exactly is a three-way handshake in transmission control protocol. Every data packet after this three-way handshake is acknowledged by ACK message, right? Acknowledgement message from the server, and server data message is acknowledged by the client. Now the fifth point is already discussed, which says every data packet is ACKed by ACK message, which is called as acknowledgement message. Now as part of synchronization message, the very important parameter is sent from the client to the server, which is window size, right? Window size means what is the amount of data that needs to be sent from client to server before acknowledgement message should come from the server, right? If there is no acknowledgement message after that particular window size data is being sent, data is again retransmitted from the client side to the server. Now this is the meaning of this is the definition of window size, where we using handshake we establish a window size of data that needs to be transmitted before acknowledgement is received. Now what is window scaling? Now there might be certain sessions where you can get high speed or high throughput can be achieved. For that, window size of 2 to the power of 16, which is 65,536 bytes, is not enough. It has to be more than that. How do you calculate window scaling parameter value? Is by multiplying the bandwidth. Let's suppose your bandwidth is 100 megabits per second, right? And the round trip delay. What is the time taken for the packet to transmit from client to server? That is called as round trip delay, and come back, right? So that is the round trip delay. So that is, for example, if it is 100 millisecond, right? So you had a connection which is 100 megabits per second and you have a round trip delay of 100 millisecond, then what you will get is you have to multiply these two terms. 100 megabits per second multiplied by 100 milliseconds will result in 10,000 kilobits per second. So which is divided by 8, right? So 10,000 kilobits per second divided by 8. Why we divide by 8 is, you know, each byte is 8 bits long. So 10,000 kilobits per second is divided by 8 to get the actual window that is required to get a high throughput for a high speed LAN networks, right? So the calculation that I did here, that is multiplying bandwidth, which is 100 megabits per second, multiplied by delay, that is round trip delay, is called as BPD, bandwidth delay product, right? That's what I mentioned in the 8 point. What is BPD? So using this BPD algorithm divided by 8, you get actual bytes that needs to be transferred on the wire or on the session to get a high throughput. But that value might be higher than 65,536. How do you do that? Is you have to shift the bytes by certain positions. So you have to multiply it by 2 to the power of 3 window size. For example, if 3 is the scaling factor, right? So you have to first negotiate that scaling factor, right? So that scaling factor is negotiated. That scaling factor can be 5, 6, 7, like that. So that scaling factor is multiplied by the window size, which is 65,536, multiplied, for example, if scaling factor is negotiated as 3, then 2 to the power of 3 is 8 into 65,536. 8 into 65,536 is the scaled window size for the session to get a throughput for that particular high throughput for that session. Okay, so that's how TCP works in a nutshell. To recap, TCP stands for Transmission Control Protocol. It provides reliable connection over transport layer. It has three-way message handshake. So client sends a SYN before sending a packet. It sends a synchronization message. The synchronization message is acted by using SYN-ACK, and SYN-ACK is acted by using acknowledgement from the client. So every data packet is acted by ACK message, right? So then we negotiate a window size for transmitting the amount of data before acknowledgement is received. If no acknowledgement received after transmitting that much of amount of data, then we retransmit the data from the client to the server. Then to check the window scaling, if we want to have high throughput, we need to scale, because what is the point in having 65,536 window size if the actual session can have more throughput? That is negotiated by using scaling factor, and that scaling factor is multiplied by the window size to get the scaled window size. And how the window size, actual window size, is calculated? that needs to be scaled is by using BPD algorithm, which is bandwidth delay product. Okay, so progressing further in the session, in the last session, which is the 7th installation of the simple home network setup concept, I discussed about CSMA-CD, which is the backbone of Ethernet technology, right? Carrier sense, multiple access, collision detection. Now, in Ethernet, there are two types of main technologies, or the Ethernet connections. One is off duplex and the other is full duplex. In off duplex, let's take an example of walkie-talkie, right? A walkie-talkie is a phone that is used by the police, where he presses a button, talks, and then releases it, and he waits for the other person to communicate. So it is off duplex. The medium is not fully utilized. First he talks and waits for the other person to respond, then he talks again. So that's how it is done in off duplex internet also. So example of off duplex Ethernet is your hub. In hub mechanism, all the packets, the packet transmitted or received by the hub is sent to all the ports. So since it's sent to all the ports will have an exact copy of the packet. But there might be collisions also. Other packets, ports may also be transmitting at the same time. So collision may happen, during which in off duplex we use CSMA-CD collision detection to determine if collision is there or not. If no collision is there, then we transmit the data. Then what is full duplex? In full duplex Ethernet, it's very simple thing is it does not require CSMA-CD. Example is layer 2 switch. There is a MAC address table being maintained in the layer 2 switch. So each port will have one mapped MAC address table, or MAC address table will have the MAC addresses mapped to each port. So a particular packet with a MAC address comes, only it will go on a particular port. It will not be sent to all the ports. So that's how layer 2 switch avoids broadcasting of the messages on all the ports. So that's what I describe here. Hub, no understanding of MAC addresses, so destination port cannot be determined. It broadcasts the packets to all ports on the hub. Everybody connected to hub will listen. Shares common collision domain, so prone to collisions. Since collision, it is off duplex, and collision is avoided by using collision detection. In layer 2 switch, there is no collision, so that's why CSMA-CD is not used. Understanding of MAC addresses is there, does not broadcast the packet to all ports, but sends to particular ports, since understanding of MAC address is there through MAC address table. Each port has its own collision domain, and hence no collision. Provides full duplex communication where we talk at the same time, like your mobile phone, you're talking at the same time, right? So these are the things that I wanted to discuss as part of this session. Hope it is helpful to all the viewers. If it is helpful, please like the video, and for future videos notification, do subscribe to the channel. Okay, thank you very much. Bye.